And now in this lecture we'll find out the radius of a circle. In the moment we have a circle, inside the circle we have chord dB. The length of chord dB is 2 units. We also have chord AC. The length of chord AC is chord of 2 units. And this is angle DEB. The size of angle DEB is 45 degrees, and our mission is to find out the radius of this circle. So, first of all, we will join points A and D together by straight line. By joining points A and D, we created here peripheral angle DAB. This is peripheral angle DAB. We define the size of this peripheral angle DAB as x over 2. So this peripheral angle DAB is subtended on chord dB. Again, peripheral angle DAB subtended on chord dB. In the next step, we'll define the center of this circle. This point is point O. In the next step, we'll join points O and B together by straight line. Likewise, we join points O and D together by straight line. By doing this construction, we actually created the peripheral angle DOB. We actually created the center angle DOB. This is center angle DOB. And this center angle DOB is subtended on the same chord called DB, exactly like this peripheral angle DAB is also subtended on the same chord called DB. So those two angles are both subtended on the same chord called DB. So now we can implement here in our drawing rule 13. So repeat quickly on rule 13. According to rule 13, a central angle is twice as large as the peripheral angle subtended on the same chord. So in the moment we have a circle, inside this circle we have, this is peripheral angle ACB, and this peripheral angle ACB. The size of this peripheral angle ACB is theta, and this peripheral angle ACB subtended on chord AB. Likewise, we have also in the drawing center angle AOB. This center angle AOB is subtended on the same chord called AB. So those two angles are both subtended on the same chord called AB. And therefore, the size of the center angle AOB will be twice as large as the size of this peripheral angle ACB, because of the fact that both of them are subtended on the same chord called AB. The size of the peripheral angle ACB is theta, and therefore the size of the size of the peripheral angle ACB is theta, and therefore the size of this center angle AOB will be equal to 2 theta. So the center angle will be always twice as large as the peripheral angle that is subtended on the same chord. So we can actually implement rule 13 in our drawing. In our drawing, we have peripheral angle DAB is subtended on chord DB. The size of this peripheral angle DAB is x over 2. And we have also center angle DOB that is subtended on the same chord called DB, and therefore the size of this center angle DOB must be twice as large as the size of this peripheral angle DAB. The size of this peripheral angle DAB is x over 2, therefore the size of this center angle DOB will be equal to x over 2 times 2, according to rule 13. X over 2 times 2 is x. We define the size of this peripheral angle ADC as y over 2. This peripheral angle ADC is subtended on chord AC. In the next step, we join points O and C together by a straight line. Likewise, we join points O and A together by a straight line. By doing this construction, we get the center angle AOC. This is center angle AOC, and this center angle AOC is subtended on the same chord called AC, exactly like this peripheral angle ADC that is also subtended on the same chord called AC. So those two angles are both subtended on the same chord called AC, and therefore the size of the center angle AOC will be twice as large as the size of this peripheral angle ADC. The size of this peripheral angle ADC is y over 2, and therefore the size of the center angle AOC will be equal to y over 2 times 2, that is y. In the next step, I'll copy the green triangle AED in a new page, and we'll implement rule 4 on this green triangle, triangle AED. So actually, this is triangle AED that I copied from the original drawing. This is angle AED. This is angle x over 2, and this angle is equals to y over 2 degrees in size. All those three angles are located inside triangle AED. Therefore, all those three angles are defined as the interior angles of this triangle AED. So, write it down. All those three angles are defined as the interior angles. of this triangle, triangle AD. While this is angle BED, and this angle BED is located outside triangle AD, and therefore this angle is defined as the external angle of this triangle, triangle AD. So if you know, this is angle BED. This angle BED is defined as the external angle of this triangle, triangle AD. So in the next step, I present to you all four, and we'll implement all four in this triangle, triangle AD. According to all four, the external angle of a triangle is equals to the sum of the two internal angles that are not adjacent to it. So in the drawing we have a triangle. Inside this triangle we have three angles, A, B and C. All of those three angles are located inside the triangle, and therefore they are defined as the internal angles of this triangle, while this is angle E. It is located outside the triangle, and therefore it is defined as the external angle of this triangle. According to this rule, all four, the size of the external angle, angle E, is equal to the sum of the two internal angles that are not adjacent to it. This is angle C, and angle C is adjacent to angle E. The two other angles that are not adjacent to it, the two other internal angles that are not adjacent to it, are A and B. And the sum of those two internal angles is A plus B. So the size of the external angle E is equal to the sum of the two internal angles that are not adjacent to it. That is to say, it is equal to A plus B. So, in conclusion, we found out that the size of the external angle E is equal to A plus B. That is the sum of the two internal angles that are not adjacent to it. So actually, we can implement all four in our drawing. Why? Because in our drawing, this is the external angle, angle BED. And according to all four, the size of the external angle BED, the size of the external angle BED is equal to the sum of the two internal angles that are not adjacent to it. This is angle EED, and this angle EED is definitely adjacent to angle BED. The two other angles that are not adjacent to angle BED are x over 2 and y over 2. And the sum of those two angles is x over 2 plus y over 2. So the size of angle BED is x plus 2 plus y over 2. According to rule 4. The size of the external angle BED is equal to x over 2 plus y over 2, according to rule 4. Again, according to rule 4, the size of the external angle BED, of the triangle AD, is equal to the sum of the two internal angles that are not adjacent to it. The two internal angles that are not adjacent to it are those two angles, x over 2 and y over 2. And the sum of those two internal angles is, of course, x over 2 plus y over 2. So in conclusion, we found out that according to rule 4, the size of the external angle BED is equal to x over 2 plus y over 2. But it is given as a question that the size of the external angle BED is 45 degrees. So we solve the angle BED by 45 degrees. And it is equal to x over 2 plus y over 2 according to rule 4. Here we multiply this equation by 2. If I get that 45 degrees times 2 is 90 degrees. So 90 degrees equals to x over 2 times 2 is x, and y over 2 plus y over 2 times 2 is y. So in conclusion, we found out that according to equation 1, x plus y equals to 90 degrees. Here we subtract x from this equation, and finally get that according to equation 1, y equals to 90 degrees minus x. y equals to 90 degrees on sector according to equation 1. In the next step, I repeat on the law of cosines, and we will implement the law of cosines in this triangle BOD and also in this triangle COA. So I repeat quickly on the law of cosines. First of all, the law of cosines is true in any triangle. So this is triangle ABC, and this triangle ABC could be any triangle. The length of side AB is A units, side AC equals to B units in its length, and side BC equals to C units in its length. The size of this angle BAC is theta. So according to the law of cosines, in this triangle ABC that could be any triangle, the following equation will be true. That cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So we can actually implement the law of cosines in any triangle, and especially we can implement the law of cosines in triangle BOD. So I copy this triangle BOD in a new page, and we will implement the law of cosines in this triangle BOD. Before that, it's very easy to see that BO equals to OD equals to OA equals to OC. All those 4 line segments are the radii of this circle. The radius of this circle, it is the radius that we are looking for in this question. We define the radius of this circle as R, and therefore OB equals to R, OC equals to R, OA equals to R, and finally OD also equals to R. So in the next step, I'll copy triangle BOD in a new page, and we will implement the law of cosines in this triangle BOD. Side DB equals to 2 units in its length, according to what is given as the question. So actually, this is triangle BOD that I copied from the original drawing. OD equals to OB equals to R. They are both the radii of the circle, so it equals to R. This is angle BOD. The size of angle BOD is X. So according to the law of cosines, in this triangle BOD, cosine X equals to OD squared plus OB squared minus DB squared minus 2 times OD times OB. So write it down. This will be equation 1. So cosine X, according to the law of cosines, of course, so I write it down, the law of cosines. According to the law of cosines, the following equation will be true. Cosine X equals to OD squared. OD is R, therefore OD squared is R squared plus OB square. OB is R, therefore OB square is R square. So it is plus R square minus DB square. DB is 2, therefore DB square is 2 squared, that is 4. So it is minus 4 divided by 2 times OD is R times OB, that is also R. Then we found out that cosine x equals to R square plus R square minus 4 over 2 times R. R square plus R square is 2R square, so in total in the numerator we have 2R square minus 4 divided by 2 times R, that is 2R square. So here 2R square over 2R square is 1, and we have also here minus 4 over 2R square. So if we found out that cosine x equals to 1, and here we have minus 4 over 2R square. Here we divide both the numerator and the denominator of this expression by 2. Minus 4 over 2 is minus 2, and 2R square over 2 is R square. So if we found out that, according to equation 1, cosine x equals to 1 minus 2 over R square. In the next step, I'll copy triangle AOC in the new page, and we'll implement the law of cosines in this triangle AOC. Actually, this is triangle AOC that I copied from the original drawing. According to the law of cosines, in this triangle AOC, cosine y equals to AO square plus OC square minus AC square over 2 times AO times OC. So write it down. According to the law of cosines, okay, again, according to the law of cosines, in this triangle AOC, cosine y equals to AO square. AO is R, therefore AO square is R square, plus OC square. OC is also R, therefore OC square is R square. So it is R square plus R square minus AC square. AC is square root of 2, therefore AC square is square root of 2 squared, that is 2. So it is minus 2 divided by 2 times AO. AO is R, therefore let's substitute AO by R times OC. OC is also R, so let's substitute OC by R. So in total we have found out that cosine y equals to r squared plus r squared minus 2 over 2 times r times r. R squared plus r squared is 2r squared. So in total, in the numerator we have 2r squared minus 2 divided by 2 times r, that is 2r squared. So cosine y equals to 2r squared minus 2 over 2r squared. 2r squared over 2r squared is 1. And we have also here minus 2 over 2r squared. So if we found out that cosine y equals to 1, and here minus 2 over 2r squared. We divide both the numerator and the denominator of this expression by 2. Minus 2 over 2 is minus 1, and 2r squared over 2 is r squared. So in conclusion, we have found out that cosine y according to equation 2, cosine y equals to 1 minus 1 over r squared. But in the beginning of the lecture, we have found out that y equals to 90 degrees minus 6. So y equals to 90 degrees minus 6. According to what we have already found out. So now we can substitute y in this equation 2 by 90 degrees minus 6. We do it now and we get that cosine y, and y is 90 degrees minus 6, equals to 1 minus 1 over r squared. So according to equation 2, we actually found out that cosine 90 degrees minus 6 equals to 1 minus 1 over r squared. We actually have the trigonometric identity that says that sinus x equals to cosine 90 degrees minus 6. And therefore, according to this trigonometric identity, we can substitute cosine 90 degrees minus 6 in this equation 2 by sinus x. We do it now, and we get that according to this equation 2, we have cosine 90 degrees minus 6, and cosine 90 degrees minus 6 is sinus x. According to this trigonometric identity, and sinus x, according to this equation 2, is equals to 1 minus 1 over r squared. This is according to equation 2. But according to equation 1, we have already found out that cosine x equals to 1 minus 2 over r squared. So we have the values of sinus x and cosine x in terms of r. In the next step, we'll use the following trigonometric identity that says that sinus square x plus cosine square x equals to 1. We already found out that according to equation 2, sinus x equals to 1 minus 1 over r squared. So if sinus x equals to 1 minus 1 over r squared, it means that Sin square x will be equal to 1 minus 1 over r squared squared. So sin square x equals to 1 minus 1 over r squared squared. And we have also here plus cosine square x. According to equation 1, cosine x equals to 1 minus 2 over r squared. If cosine x equals to 1 minus 2 over r squared, it means that cosine square x will be equal to 1 minus 2 over r squared squared. And it is equals to 1. Again, sin square x is 1 minus 1 over r squared squared. And cosine square x is 1 minus 2 r squared squared. According to this trigonometric identity, it is equals to 1. So here also it is equals to 1. In the next step, we define t as 1 over r squared. So now we can substitute 1 over r squared in this equation 3 by t. We do it now, and we get that we have here 1 minus 1 over r squared, and 1 over r squared is t. So we substitute 1 over r squared in this equation 3 by t, and get 1 minus t squared. So in total, this expression will be equal to 1 minus t squared. And we have also here plus 1 minus t over r squared. Here we multiply this expression by 1. Actually, it is allowable to multiply any expression by 1, because by multiplying the expression by 1, we will not change the value of the expression. So here we have 1 minus 2, so it is minus 2, 1 times 1 over r squared. 1 over r squared is t, so we substitute 1 over r squared by t. So in total, this expression will be equal to 1 minus 2t squared, and this equals to 1. So we found out that according to equation 3, 1 minus t squared plus 1 minus 2t squared equals to 1. So here we will open the brackets on this side of this equation 3, and we get that according to this equation 3, we have here 1 minus t squared. 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2t plus 1 minus t squared. 1 minus 2t squared. 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared. 2t squared is 4t squared, minus 2 times 1 times 2t is minus 4t, and it is equals to 1. So here we have 1 on both sides of this equation 3, so 1 will get cancelled. After we cancelled 1, in this side of the equation 3 we have t squared plus 4t squared is 5t squared. And we have also minus 2t minus 4t is minus 6t, plus 1 equals to 0. So if we found out that according to equation 3, 5t squared minus 6t plus 1 equals to 0. Repeat again. According to equation 3, we actually found out that 5t squared minus 6t plus 1 equals to 0. So this is a quadratic equation, And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say 5t squared minus 6t plus 1 equals to 0, the variable that we are looking for is t. So x equals to t, the coefficient a equals to 5, the coefficient b equals to minus 6, and finally the coefficient c equals to 1. The only thing that is left to do is to put this data of our specific quadratic equation inside this general formula for x, and in this way we will find out the value of the values of t, because x equals to t. So we'll do it now, and we'll get that x equals to t, so we substitute x by t, and it is equals to minus b. b is minus 6, therefore minus b is minus 6, that is plus 6, plus minus square root of b squared. b is minus 6, therefore b squared is minus 6 squared, that is 36, minus 4 times a is 5, so minus 4 times 5 is minus 20, times c is 1, so minus 20 times 1 is minus 20, divided by 2a. a is 5, so 2 times a is 2 times 5, that is 10. So in conclusion, we have found out that t equals to 6 plus minus, inside the root we have 36 minus 20 is 16, so inside the root we left only with 16 divided by 10. So t equals to 6 plus minus, the square root of 16 is 4 divided by 10. So here we will have two solutions that are possible for t. We actually found out that t equals to 6 plus minus 4 over 2. Repeat again, here we will have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 divided by 10. Again, we have two solutions that are possible for t. T equals to 6 plus 6 plus minus 4 over 10. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. Six plus 4 is 10, and 10 over 10 is 1. So the first solution for t is that t equals to 1 from one side. But from the other side, according to our definition, t also equals to 1 over r squared. So now we can substitute t in this equation by 1 over r squared. We'll do it now, we'll get that 1 over r squared equals to 1. Here we multiply this equation by r squared, and finally we get that r squared equals to 1. R squared equals to 1. We'll take a root out of this equation, and finally we get that the radius r is equals to the square root of 1, that is 1. So So if we found out that the radius of this circle equals to 1. But it is actually impossible that the radius of this circle is equals to 1. Why? Because we know that chord dB equals to 2 units in there. Chord dB is equals to 2 units in there. It is very easy to see from the drawing that chord dB is definitely not the diameter of this circle. Again, chord dB is not the diameter of this circle. So the diameter of this circle must pass through the center of the circle, and chord dB is definitely not the diameter of the circle. So I write it down. Chord dB is not the diameter of the circle. And we also know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. What is the diameter of this circle? The diameter of this circle is of course equals to 2r. Because again, the diameter of 2r is the longest chord in the circle, and therefore it is definitely must be greater than dB, that is not the diameter. Again, the diameter of 2r must be greater than dB, that is not the diameter, but dB equals to 2. And for this equation, 2r is greater than dB, is equals to 2. We will derive that 2r is greater than 2. 2r is greater than 2. Here we will divide this inequality by 2. And finally we get that the radius r must be greater than 1. So if I found out that the radius r of this circle must be greater than 1 unit. The radius r must be greater than 1 unit. If the radius r must be greater than 1, the radius r cannot be equal to 1. So the radius r cannot be equal to 1. Therefore, we cancel this solution. And therefore, actually left only if the second solution, the first solution that t equals to 1 will give us a contradiction. So the first solution t equals to 1 is the incorrect solution, and therefore we will take into account only the second solution for t. And the second solution for t is that t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So according to the second solution for t equals to 1/5 from one side, but from the other side, according to our definition, t also equals to 1 over r squared. And therefore we can substitute t in this equation by 1 over r squared. We do it now, and we get that 1 over r squared equals to 1/5. Here we first multiply this equation, and finally get that r squared equals to 5. Here we take a root out of this equation, and finally get that r, that is the radius that we are looking for, the radius of the circle, is equals to either the square root of 5 units in its length, or in terms of numbers, it is equals to 2.236 units. And this is the answer to the question. Repeat again, we found out that the radius r of this circle is equals to either the square root of 5 units in its length, or in terms of numbers, the radius r of this circle is equals to 2.236 units. Okay? So in the next step, I'll summarize the lecture. In this lecture, we found out the radius of this circle. So in the normally we have a circle. Inside the circle we have chord dB. The length of the chord dB is 2 units. We also have chord AC. The length of chord AC is chord of 2 units. This is angle DEB. The size of angle DEB is 45 degrees. Again, our mission is to find out the radius of this circle. So in the first step, we join points A and D together by a straight line. By joining points A and D, we get the peripheral angle DAB. This is peripheral angle DAB. We define the size of this peripheral angle DAB. Peripheral angle DAB is x over 2. This peripheral angle DAB is subtended on chord DB. Again, peripheral angle DAB is subtended on chord DB. In the next step, we define the center of this circle. This point is O. Then we join points O and B together by a straight line, and we join points O and D together by a straight line. By doing this construction, we get this center angle DOB. This is center angle DOB. This is center angle DOB subtended on chord DB. So those two circles, those two angles, they are both subtended on the same chord called DB. So now we can implement here Rule 13. I'll repeat quickly on Rule 13. According to Rule 13, the central angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing we have a circle. Inside this circle we have peripheral angle ACB. This is peripheral angle ACB. The size of peripheral angle ACB is theta, and this peripheral angle ACB is subtended on chord AB. In addition, inside this circle we have center angle AOB. This is center angle AOB, and this center angle AOB subtended on the same chord called AB. So those two angles are both subtended on the same chord called AB. And therefore, according to this rule, Rule 13, the size of the center angle AOB will be twice as large as this peripheral angle ACB. This peripheral angle ACB, the size of this peripheral angle ACB is theta, and therefore the size of the center angle AOB will be equal to 2 theta. So the center angle is twice as large as the peripheral angle that is subtended on the same chord. Okay, so we can implement Rule 13 in our drawing. Why? Because in our drawing, those two angles are both subtended on the same chord called DB. And therefore, the size of the center angle DOB will be twice as large as the size of this peripheral angle DAB. The size of this peripheral angle DAB is x over 2. Therefore, the size of this center angle DOB must be equal to x over 2 times 2, that is x. Okay, the size of this center angle DOB is x, according to Rule 13. In the next step, we define the size of this peripheral angle ADC. This angle is 5 over 2. Then we join points O and C together by a straight line, and join points O and A together by a straight line. By doing this construction, we get the center angle AOC. This is center angle AOC, and this center angle AOC is subtended on chord AC. Exactly like this peripheral angle ADC, it is also subtended on the same chord called AC. So those two angles are both subtended on the same chord called AC. And therefore, according to Rule 13, the size of this center angle AOC will be twice as large as the size of this peripheral angle ADC. The size of this peripheral angle ADC is y over 2, and therefore the size of this center angle AOC will be equal to y over 2 times 2, that is y. Okay, the size of this peripheral angle AOC is y. So, in the next step, I actually presented to you the law of cosines. Actually presented to you all 4, and implemented all 4 in this great triangle, triangle DEA. So, in the first step, I actually copied this great triangle DEA in a new page, and we implemented all 4 on this great triangle, triangle DEA. This is the great triangle DEA, is a copy from the original drawing. Inside this triangle DEA, we have this angle DEA, and those two angles, y over 2 and x over 2. All those three angles are defined as the interangles of this triangle DEA. Why? Because of the fact that all of those three angles are located inside this triangle, triangle DEA. This is angle BED that is located outside triangle DEA, and therefore it is defined as the external angle of this triangle, triangle DEA. So in the next step, I presented to you all 4 and implemented all 4 in this triangle, triangle DEA. According to all 4, the external angle of a triangle is equal to the sum of the two interangles that are not adjacent to it. So in the drawing we have a triangle. Inside this triangle we have three angles, A, B, and C. And therefore all those three angles are defined as interangles because they are located inside the triangle. While this is angle A that is located outside this triangle, and therefore this angle is defined as the external angle of this triangle. And according to this rule, rule 4, the size of the external angle E is equal to the sum of the two internal angles that are not adjacent to it. This is an angle C that is definitely adjacent to angle E. And the other two angles that are not, the other two internal angles that are not adjacent to this angle E are A and B. And the sum of those two angles is of course A plus B. So according to this rule 4, the size of the internal angle E is equal to A plus B, that is the sum of the two internal angles that are not adjacent to it. Again, we have found out that according to rule 4, the size of the internal angle E is equal to A plus B. And A plus B is the sum of the two internal angles that are not adjacent to angle E. So we can actually implement rule 4 in our drawing. Why? Because in our drawing we have, this is the external angle BED, and according to rule 4, the size of the external angle BED must be equal to the sum of the two internal angles that are not adjacent to it. This is angle AED that is definitely adjacent to this angle BED. The other two internal angles that are not adjacent to this angle BED are those two angles. And the sum of those two angles is of course x over 2 plus y over 2. In conclusion, we found out that according to rule 4, the size of the external angle BED is equal to x over 2 plus y over 2. And again, the size of the external angle BED of triangle AED is equal to x over 2 plus y over 2 according to rule 4. That is actually the sum of the two external angles that are not adjacent to angle BED. So angle BED equals to x over 2 plus y over 2. But it is given as an equation that the size of angle BED is 45 degrees. Therefore, we can substitute angle BED by 45 degrees. And we shall find out that 45 degrees equals to x over 2 plus y over 2. Here we multiply this equation by 2 and finally found out that 45 degrees times 2 is 90 degrees, x over 2 times 2 is x, and y over 2 times 2 is y. So we shall find out that 90 degrees equals to x plus y. Here we subtracted x from this equation and finally found out that y equals to 90 degrees minus x. Again, according to equation 1, y equals to 90 degrees minus x. So, what is the definition of line segment AO? Line segment AO starts from point O, that is the center of this circle, and that's at point A, that is the point on the circle itself. So this is exactly the definition of a radius. Therefore, OA is the radius of this circle. We define the radius of this circle as R. R is the radius that you're looking for in this question. So OA equals to R. It is the radius of the circle that is equals to R. And therefore, all the other three line segments, OD, OB, OC, they are there of this circle is equals to R. So all of them, each of them is equals to R. In the next step, I copied triangle BOD in a new page, and we implemented the law of cosines in this triangle BOD. So I repeat quickly on the law of cosines. The law of cosines is true in any triangle. This is triangle ABC that could be any triangle. The length of side AB is 8, side AC equals to B units incident, and side BC equals to C units incident. The size of the angle BAC, this angle is theta. According to the law of cosines, in this triangle ABC that could be any triangle, the following equation will be true, that cosine theta equals to A square plus B square minus C square over 2 times A times B. Again, cosine theta equals to A square plus B square minus C square over 2 times A times B. We can implement the law of cosines in any triangle, and especially we can implement the law of cosines in this triangle BOD. So copy triangle BOD in a new page and implemented the law of cosines in this triangle BOD. Actually, this is triangle BOD, it is the point from the original domain. Side OD equals to side OB equals to R, they are there of the circle, is equals to R. DB equals to 2 according to what is given as the question. The angle DOB equals to X. According to the law of cosines, in this triangle DOB, cosine X equals to OD square plus OB square minus DB square over 2 times OD times OB. So cosine X equals to OD square. OD is R, therefore OD square is R square. Plus OB square. OB is R, therefore OB square is R square. Minus DB square. DB is 2, therefore DB square is 2 squared, that is 4, so it is minus 4. So in total, in the numerator we have R square plus R square minus 4, divided by 2 times OD, that is R, times OB, that is also R. So in total, in the denominator we have 2 times R times R. So in conclusion, we found out that according to equation 1, cosine X equals to R square plus R square, that is 2R square, minus 4 over 2 times R, that is 2R square. So cosine X, in total according to equation 1, cosine X equals to 2R square minus 4 over 2R square. So cosine X equals to 2R square over 2R square is 1, and we have also here minus 4 over 2R square. Here we divided both the numerator and the denominator of this expression by 2, and finally found out that cosine X equals to 1, and here we have minus 4 over 2 is minus 2, and 2R square over 2 is R square. So in total, actually found out that according to equation 1, cosine X equals to 1 minus 2 over R square. In the next step, I copied triangle AOC in a new page and implemented the law of cosines in this triangle AOC. This is triangle AOC. And I copied from the original domain. Side AC, the length of side AC is equal to 2, AO equals to OC equals to R, they are both there of the circle, that is equals to R, according to our definition. This triangle AOC, according to the law of cosines, cosine Y equals to OA square plus OC square minus AC square over 2 times OA times OC. Again, cosine Y equals to OA square plus OC square minus AC square minus 2 times OA times OC. So cosine Y equals to OA square. OA is R, therefore OA square is R square, plus OC square. OC is also out, therefore OC square is R square, minus AC square. AC is square root of 2, therefore AC square is square root of 2 squared, that is 2. So in total, in the numerator, we have R square plus R square minus 2 divided by 2 times OA, OA is R, times OC, that is also R. So in total, in the denominator, we have 2 times R times R. So in conclusion, we found out that according to equation 2, cosine y equals to R square plus R square, that is 2R square, minus 2 divided by 2 times R, that is 2R square. So we found out that according to equation 2, cosine y equals to 2R square over 2R square is 1, and we have also here minus 2 over R square. Here we divided this expression, both the numerator and the denominator of this expression, by 2. And we found out that cosine y equals to 1, and here we have 2 over 2, minus 2 over 2 is minus 1, and 2R square over 2 is R square. So according to equation 2, we found out that cosine y equals to 1 minus 1 over R square. This is according to equation 2. Well, we already found out in the beginning of the lecture that y equals to 90 degrees minus 6. So now we can substitute y in this equation 2 by 90 degrees minus 6. We did it. We actually found out that cosine y, here y is 90 degrees minus 6. So cosine y is cosine 90 degrees minus 6. And it is equals to 1 minus 1 over R square according to equation 2. But we have the trigonometric identity that states that sine of x equals to cosine 90 degrees minus x. Therefore, we can substitute, according to this trigonometric identity, we can substitute cosine 90 degrees minus x by sine of x. We did it. Actually found out that, again, cosine 90 degrees minus x is sine of x according to this trigonometric identity. And sine of x according to equation 2 is equals to 1 minus 1 over R square. This is according to equation 2, while according to equation 1, we have already found out that cosine x equals to 1 minus 2 over R square. So we have the values of sine of x and cosine x in terms of R. Now we use the trigonometric identity that states that sine square x plus cosine square x equals to 1. According to equation 2, sine of x equals to 1 minus 1 over R square. And the whole sine square x will be equal to 1 minus 1 over R square squared plus cosine square x. Cosine x according to equation 1 equals to 1 minus 2 over R square, 1 minus 2 over R square, and therefore cosine square x will be equal to 1 minus 2 over R square squared. 1 minus 2 over R square squared, and it is equals to 1 according to this trigonometric identity. Here is, we define t as 1 over R square. So t equals to 1 over R square according to our definition, therefore we can substitute 1 over R square in this equation 3 by t. We did it, and we actually found out that this expression is equals to 1 minus 1 over R square. 1 over R square is t. So we substitute 1 over R square by t. So in total, this expression will be equal to 1 minus t squared. 1 minus t squared. And we also here plus 1 minus 2 over R square. So we multiplied this expression by 1. And this expression equals to 1 minus 2 times 1 over R square. Now we substitute 1 over R square by t. So this expression will be equal to 1 minus 2t squared in total. This expression in total will be equal to 1 minus 2t squared equals to 1. Here we open the brackets on this side of this equation, equation 3. And finally found out that according to this equation, equation 3, 1 minus t squared equals to 1 squared plus t squared minus 2t, and we have also here 1 minus 2t squared. 1 minus 2t squared equals to 1 squared plus 2t squared. 2t squared is 4t squared minus 4 times, minus 2 times 1 times 2t is minus 4t, and it is equals to 1. So here we have one both sides of this equation 3. So one we get cancelled, also cancelled 1. In the side of the equation we left only with t squared plus 4t squared is 5t squared. And we have also minus 2t minus 4t is minus 6t plus 1 equals to 0. In conclusion, we can find out that according to equation 3, 5t squared minus 6t plus 1 equals to 0. And again, we can find out that according to equation 3, t squared minus 6t plus 1 equals to 0. So this is a quadratic equation. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say 5t squared minus 6t plus 1 equals to 0, the variable that we are looking for is t. So x equals to t, the coefficient a equals to 5, the coefficient b equals to minus 6, and finally the coefficient c equals to 1. The only thing that is left to do is to put this data of our specific quadratic equation inside this general formula for x, and in this way we find out the value of the values of t, because x equals to t. So we did it, and here x equals to t, so we substitute x by t. So t equals to minus b. B is minus 6, therefore minus b is minus 6, that is plus 6, plus minus square root of b squared. B is minus 6, therefore b squared is minus 6 squared, that is 36, minus 4 times a. A is 5, so minus 4 times 5 is minus 20, times c. C is 1, so minus 20 times 1 is 20. So inside the root we have 36 minus 20 divided by 2a. A is 5, so 2 times a is 2 times 5, that is 10. So we should find out that t equals to 6 plus minus. Inside the root we have 36 minus 20, that is 16. So inside the root we left only with 16 divided by 10. So t equals to 6 plus minus the square root of 16 is 4 divided by 10. So in total we can find out that t equals to 6 plus minus 4 divided by 10. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. So according to the first solution for t equals to 1 from one side. But for the other side, t is also equals to 1 over r squared according to our definition. And therefore we can substitute t in this equation by 1 over r squared. We did it. And we found out that 1 over r squared equals to 1. Here we multiply this equation by r squared, and finally found out that r squared equals to 1. Here we took out of this equation, and finally found out that r equals to the square root of 1, that is 1. So according to the first solution for t, the values of this circle, r is equals to 1. But it is actually impossible that the values of this circle r will be equal to 1. Why? Because of the fact that we know that code db equals to 2 units itself, according to what is given in the equation. And it is very easy to see that code db is not the diameter of the circle. Again, code db is not the diameter of the circle. Code db equals to 2, and code db is not the diameter of the circle. It is very easy to see it from the drawing. And you note that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. What is the diameter of this circle? The diameter of this circle is of course 2r. So the diameter of 2r is the longest chord in the circle, and therefore it is definitely greater than db. It is not the diameter of the circle. So 2r is greater than db, and db equals to 2. And from this equation, 2r is greater than db equals to 2. We will derive that 2r is greater than 2. Here we divided this inequality by 2, and finally found out that the radius r is greater than 1. The radius r of this circle is greater than 1. if the radius r is greater than 1, the radius cannot be equal to 1. Again, if the radius r is greater than 1, the radius r cannot be equal to 1. So you can set the solution. And we have, so the first solution for t, that t equals to 1, leads us to a contradiction. And therefore, we present the first solution for t equals to 1 is the correct solution, and only the second solution for t is left. So we take into account only the second solution for t. The second solution for t is that t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So the second solution for t is that t equals to 1/5 from one side, but from the other side, according to our definition, t also equals to 1 over r squared. And therefore, we can substitute t in this equation by 1 over r squared. We did it, and we found out actually that 1 over r squared equals to 1/5. Again, 1 over r squared equals to 1/5. We multiplied this equation, and finally found out that r squared equals to 5. We took a root out of this equation, and finally found out that the radius r of this circle is equals to either the square root of 5 units in itself, or in terms of numbers, the radius r of this circle is equals to 2.236 units. Okay, thank you very much.